Okay, today we will be covering the lens. Like the last week, we've gone through the mirrors, and then we have gone through how to trace, uh, how to draw the ray diagrams for the mirrors, and then I've also explained to you about the sign conventions. I mean the value of P as well as the value of Q. Both P and Q, we have to decide their sign a negatively should be a negative value, or Q should be a positive value. So we learn on how to determine whether they are positive numbers or negative numbers. And then for today, we will be using the same concept, but now we are dealing with the lenses. And of course, when we have the mirror, we do have reflection. So I've also explained to you about the inbound and outbound region. So for the mirror, the inbound and the outbound region is in the same side, which is in front of the mirror. So for lenses, it will be a bit different. So I'll go through that. Okay. So this is just a recall, yeah. I'm afraid you are not able to remember. Maybe some of you won't be able to, some of you do not remember this. I'll re-explain to you on determining the sign for the mirrors. I mean, the sign of P and Q for the mirrors. So if you could remember, I've explained to you on how to divide the region here into several parts. So of course, this is the middle line. This is the region where you place your mirror or your lens. So here should be either mirror, a concave mirror, or a convex mirror, or maybe here is a convex lens as well as the concave lens. So again, I repeat, the concave lens should be like this, yeah. So it should be thinner at the center and then thicker at both ends. I mean at the edges. So now you know that your glass should be here, or your mirror should be here. I mean your lens should be in the middle here. So this is the lens or the mirror position. So first, I need you to not remembering things, okay? You don't have to remember this. You don't have to remember, okay, for lens on the left hand side should be P minus. You don't have to remember about that. But the thing is, whenever whenever you came across things, I mean, if you are required to draw the ray diagrams, or if you are required to predict or estimate the position of the image or the object, so you need to know how to determine the sign. Okay, the sign, whether the value of P is greater than 0 or the value of P is less than 0. So of course, for the P here, the magnitude of P is the distance of the object from the mirror or the lens. But of course, your object, maybe your object is on the left hand side, and sometimes your object is on the right hand side. So there are cases where your image is forming over here, and then maybe your image is forming over here. So it depends on the situation, okay? So so the thing is, if you try to memorize things, then you will feel burdened, okay? You don't have to feel burdened because there is a trick on how to know this, yeah? So first things first, you need to divide the regions into two regions, into two sub-regions, yeah? So this is region 1, which is, we call that as in front of the mirror or lens. So this is behind the mirror or lens. So the right hand side here, the right hand side region is behind the mirror. Okay. So now next we have the principal axis. So this is the principal axis. So the principal axis is, I mean, it should be horizontal, and then it should go through the center of your mirror or your lens. So if you want to draw your lens, you need to make sure that the principal axis go through the center of the glass or the mirror. So it should be at the center. Okay, you need to remember about that. Okay, and then if you want to put your mirror, should place it like this so that the principal axis go through the center of the mirror. So this is the side view of the mirror. So when you take the cross-sectional view, your mirror, either concave or convex, should looks like this lah. Should looks like a circle. So this is the center of the lens or mirror. So the principal axis should go through the center here. Okay. But most of the time, we are more likely to view it from the side. Okay, we are not going to draw any diagrams using the cross-sectional view. We are only using the side view. Okay, and of course, for your mirror, let's say this is the region where you put your mirror. This is your mirror, so I just approximately draw my mirror here lah. So this here is the mirror. The mirror here should be either the concave or convex or I mean or just a plain mirror. Now, suppose that you have your object over here. So this side is the surface of your mirror. Okay, so this is behind your mirror. So of course, behind your mirror, the surface is dull. So maybe it is being coated with something. So normally we put our object in front of the reflecting side lah. Okay, this is very intuitive, yeah. Even if I talk to your younger brother, I mean 5-year-old brother or sister, they will know this. So if you put your object over here, so it is meaningless lah. Okay, it is meaningless because it won't be reflecting any lights because the behind of the mirror itself is coated with, I mean, some sort of materials. I don't know what's the material is. So normally we have our object here. Okay. Well, we also, in some cases, I mean, unconventionally lah, okay? Unconventional. It is unconventional for us to put the object here. So meaning to say we are assuming that this particular side is the reflecting side. So again, yeah, it is the same. So you don't have to worry too much about that. And then most of the questions from the textbooks, as well as the examination papers, as well as my tests or assignments, I'll put the object in front of the mirror on the left hand side. So the reflecting surface is on the left hand side region. Okay, so it is meaningless to put it here. So again, you put your mirror at the center here. So of course, this is your object. Your object must be in front of the mirror. Okay, so if I project the light ray from here to here, and then this is what we call the incoming light ray. Okay, this is the incoming light ray. So the incoming light ray is in the inbound region. Is in the inbound region. So the value of P here is positive. The value of P is positive. And then there are cases where we have our object here, but the thing is, you need to understand that this particular object is being produced by the other mirror, meaning to say we have a system of 2 or more mirrors. So we have the first mirror producing the image over here, and then the image over here is being reflected by other mirrors. So it is still possible, But normally in most tests or most questions, we don't really put our object here. But still there are cases. I'm not sure whether we have that in our previous questions past sidang. I'm not sure about that. So should be the object should be here. Okay. So if your incoming ray, this is the inbound ray, is on the left hand side. So your P is positive. So your P is positive, greater than 0. So this is the inbound region. And then of course, it is not possible for the light ray to penetrate through the mirror. It is not possible at all. So most of the time, most of the time it will reflect. Okay, it will reflect. It will reflect the light ray. So the reflected ray must be in the left-hand side region. So of course, the left-hand side region is the inbound region, the in region, as well as the outbound region is the left-hand side region. So this is also the outbound region, because of course, the outgoing rays will be on the left-hand side region. Okay, so the left-hand side region is the inbound region as well as the outbound region. So whenever your image is being produced here, then your value of P is positive, greater than 0. Okay. For some reason, your image will be produced behind the mirror. But the thing is, you need to remember that there's nothing behind the mirror, but it is our brain that evaluates that kind of light rays convergence. So it's our brain. So the mirror is tricking our brain such that when we look the light rays into our eyes, it seems that the light rays are coming from behind the mirror, but it is actually not, because the mirror itself is tricking us. It is reflecting the rays. And then what else? At some point, your image is being produced behind the mirror. So this is the forbidden region. It is not possible for the light rays to be located behind the mirror. So meaning to say, the image itself is virtual. Because the image itself is being produced behind the mirror, so it is not logical. So that's the reason why we call it as the virtual image. Based on our intuition, the light rays should be on the left-hand side. Because here, for the mirror, the inbound region is on the left-hand side, as well as the outbound region, which is also on the left-hand side here, in front of the mirror. When I mention about left-hand side, it means that it is in front of the mirror. So whenever you have your image here, then your Q here is less than 0. Anything that lies in the forbidden region is negative. Okay? Anything that lies in the forbidden region, then it is negative. Let's say if your Q here, your image here is being produced behind the mirror, which is the forbidden region, then the value of Q must have, or the value of Q possesses the negative sign. Okay, you should put the negative sign. And then the magnitude of your Q is the distance from here to your image. Okay, from here to here. So I hope you are okay with the convention here. So you don't have to remember things. Firstly, I need you to know how to divide the region into 2 sub-regions. And then you need to identify the forbidden region. So for this particular case, which is for the mirror, the forbidden region is the right hand side region. So the right hand side region here is actually behind the mirror. So now, of course, I'm going to go through the case for lenses. Yeah, before that, of course, I need you to remember, not to remember, to know this as well. So you are able to use the same concept or the same trick here in order to know whether the focal point of your mirror is positive or negative. So let's say this is a convex mirror. So your convergence point is in the allowed region. So this is in front of the mirror. So this is the inbound region as well as the outbound region. Okay. So your rays are converging in the allowed region. So your F here should be positive. So basically for the concave mirror like this, the rays are converging at a point and then at the focal point where the focal point itself is not in the forbidden region. So meaning to say, if the focal point is not in the forbidden region, then it should be F. The focal point should be greater than 0. And then we have another case where we have the convex mirror. So your ray will be coming from the left and then it will get reflected. And then if you include as many rays as you wanted to, so it will reflect it like this, and then it seems to be diverging. I mean, the outgoing rays are diverging. So it is not converging. So the rays are not converging. So for the convex mirror, the rays are diverging. So when we extend the rays, it seems that the focal point is behind the mirror. So the focal point itself lies in the forbidden region. So the value of F is less than 0. Again, I repeat, if the focal point lies inside the forbidden region, then um, its value must be less than 0, which is negative. Okay? Now, let's go to the lenses. First of all, I need you to bear in mind about the focal length and the focal point of the lenses. And of course, when I mention the lens, I need you to bear in mind that the lens itself is a thin lens. Because in our physics application, in our life application, we will always be using most of the time we will use the thin lens, okay? Especially for your contact lenses, and then you have your glasses, your spectacles, and then we also have our projector. And then if we I don't know whether you notice this, we have two different headlights. Your car, for your car, we have two different types of headlights. So we have the one which is the older version, which is based on the retroflexion. So based on retroflexion, and then we have another one which is based on projection. So for the case of projection, the headlights itself, the headlamps, the housing of the headlights, not the bulb. The housing of the headlights, most modern cars, they are using the convex lens, yeah, in order to focus the light rays. This is the bulb, of the car headlights, and they have some sort of like a lens here, so that it will focus the light into a certain direction. Okay, so it is something like that. That's the application of lens. And then what else? We do have lenses in our camera. In fact, we have more than one lens in the camera. And then, well, you can just Google about that. I mean, the application of lens as well as the mirrors. But the thing is, you need to know the details of the lens itself. First, the lens itself, I mean, the thin lens is characterized by the focal point. Okay, it is characterized by the focal point. So, for example, if you have your mirror, your mirror is also characterized by the focal point. So, um, let's say you have a shorter focal point, then your mirror will be more curved. You see what I mean? Meaning to say, let's say if I have my curve mirror, then the focal point will be somewhere here. And then if I have a slightly curved mirror, then the focal point should be somewhere here, which is farther than the previous, than this particular mirror. Same goes to the lenses. So if I have a lens which is which have I mean if I have my lens here which is very convex, I mean the radius of curvature is short, so my focal point will be somewhere here or here. And then I need you to bear in mind that the focal points for the lens is like this. Okay, firstly, there are two focal points because the light rays are coming from the right hand side. Here is the right hand side, and then it is also, they are also coming from the left hand side. So it depends on your situation. If you are referring to the light rays coming from the left hand side, then your focal point will be this one. Sorry, it actually depends on the lens. Let's say if the lens is a convex lens, then your focal point will be this one. If it is a concave lens, so your focal point will be this one. So I'll show you later, yeah, about this. Meaning to say, there are two focal length. There are two focal points. Okay, let's say if I have my lens here, there are actually two focal points. But it actually depends on your situation. If you are referring, let's say if you have a problem, you are trying to answer my questions, and then my questions are referring to the light rays coming from the right hand side, then you have to choose this one. For example, I'll show you on how to choose, yeah, on how to choose the focal points after this. So it depends on the situation, yeah. So meaning to say, there are two focal points, but there is only one focal length because the distance between, the distance between the lens and the focal point here should be the same with the distance from the lens to the focal point over here. So the length should be the same. So this is F, this is also F. But depending on the situation, it is either positive F or negative F. So it depends on the situation as well as the type of lens. Either it is a converging lens, which is the concave lens, or the convex lens. There are two focal points, but there is only one focal length. Okay, you need to remember this. Yeah. The reason why I'm giving you that kind of statement is because if you have a lens at the center here, the light rays can be coming from the right hand side, or it could be, I mean, they can be coming from the left hand side as well as the right hand side. So it depends on your situation. If your object is on the left hand side, then you should be only considering the light rays coming from the left hand side. So you'll be ignoring the light rays coming from the right hand side. You throw this away. And then your focal point will be depending on the rays here. Okay. For example, here I have a convergence lens. And then the light rays are coming from the left hand side, and then it will get, and then they will get refracted through the glass, refracted by the glass, and then all of these rays will be converging at a single point. So we have our light rays coming from the left hand side, and then it will converge to a point here. And of course, we also have our focal point on the left hand side, and then we have another focal point on the right hand side. There are two focal points here, but the thing is, you are focusing on the light rays coming from the left hand side, then your focal point should be here. Then this is your focal point. So whenever you do your calculation, you will be using the focal point which is located here. Now, I need to disseminate to you, I need to elucidate you on how to determine whether the focal point is positive or negative. Because when I go through the lecture slides here, they tend to be a bit confusing. So I'll just use my convention. I'm using this particular slide, and then bear in mind that for the mirrors, I need you to put this over here, yeah, because the inbound as well as the outbound region is on the left hand side. So it is not possible for the light rays to be located on the right hand side here, because the mirror itself is a reflecting surface. So no lights will go through the mirror. And then now we have our lens. Instead of putting a mirror here, we have our lens. Now let's consider the convex lens. So I have my convex lens. Hopefully you guys are able to remember the reason why I call this as a convex, because there are no caves. There is no cave, so this is a convex. If there is a cave here, let's say going from here to here, there's a hollow part here, okay? Then we call that as the concave. So this is the convex mirror. And of course, if you are considering the light rays coming from the left-hand side, then this is your in region. And then if you have your object here, let's say if I draw my object here, then your object defines the inbound region. Your object should be either here or here. But now, let's say if I put my object here, so this is actually the left-hand side is actually the inbound region. And of course, for the lens, it is not possible to have P which is less than 0. It is not possible to have negative P, because for the lens, the object can be either here or here. So it is, you can flip. It is symmetric. So there is actually no negative P for the lens. This is quite intuitive, yeah. If you put your object here, then this side is your inbound region. And of course, your P is located in the inbound region. Then your P should be positive. Unless if you change this with a mirror. So if you put your object behind the mirror, so it is non-intuitive. Yeah, I mean, it is not logical to put our object behind the mirror. So for that particular case, our P is less than 0. We have a negative P. That is only for the mirror. And then there are cases involving multiple mirrors. It is possible to have your object behind the mirror. Okay, but I won't give you that kind of questions lah. You don't have to worry. But still, it is possible, yeah. Yeah. Now we are focusing on the lens, so we can also have our object on the left-hand side or the right-hand side. Meaning to say, if you have your object on the right-hand side, then the value of P is greater than 0 because here the right-hand side here is your inbound region. So for lens, the inbound region can either be here or here. And of course, the inbound region must contain the object. Okay, so your object is here, then here is your inbound region. And then your value of P is greater than 0. It is very intuitive. And then I apologize that I'm making this quite complicated for you to listen and try to process what I've said. But it is actually intuitive lah. Yeah, I'm trying my best to explain this, yeah. And of course, if you have your object coming from the left-hand side, so I draw again, this is my object coming from the left-hand side. And then, of course, this is my inbound region because I have my object here. First things first, you need to divide the region into two sub-regions, okay? And then you need to identify which one is the inbound region, which is the outbound region. The thing is, if you want to know whether it is an inbound region or outbound region, you need to identify the forbidden region. So of course, for the mirror, the forbidden region is behind the mirror because it is not possible for the light rays to go through the mirror. But now I have my glass here at the center. The outbound region will be on the right-hand side. The reason is because my light rays are supposed to be penetrating the lens. And the reason why I put this at outbound region, because the region here is where your outgoing light rays should be. So the outgoing light rays should not be here. So the left-hand side is the forbidden region for the outgoing light rays because it is not possible for the light. If you consider the internal reflection, then it is possible. But now I need you to throw away that kind of thinking. I need you to assume that all of the light rays are being refracted. So it is not possible to have our light rays coming from here and then gets reflected back. We are assuming that, yeah? We are assuming that. So if your image is located over here, this is your image, yeah? I put this as I. So if this is your image, then your Q must be negative. If your image is located in front of the lens, then it should be minus Q. Because the image itself is located in the forbidden region. It is not possible for the light rays to be located over here, which is in the inbound region. It is not possible. It is not possible. So whenever the image is being formed in the forbidden region, meaning to say the image is virtual. The reason why we call that as virtual is that the image itself is being how to say, is being produced by our brain. So it seems that the image is being produced in front of the mirror, but actually we are being tricked by the lens. So actually the light rays are entering the glass, and then because it is diverging on the right hand side, so and then we extend our light rays, and then the image is formed in front of the mirror. So it should be minus Q. Okay, again, I repeat, in order to know whether your P or Q is positive or negative, you need to divide your geometry, your region, into two regions. And then you identify where is your object located. If my object is over here, then this is my inbound region. And then in order to know the outbound region, since we are using the glass, so the light rays will go through the glass. And then we will expect that the light rays, the outgoing light rays, will be located on the right hand side here. So this is the outbound region. This is our expectation, yeah? So if your object lies inside the inbound region, well, for the lenses, the value of P must always be greater than 0. So your P here should be positive. And then there are cases where your image is being produced here. So since your image is in the outbound region, then the value of Q is positive. Okay? And then we have another case where your image is being produced in front of the mirror. This is your image, yeah? I denote with I. So let's say if your image is being produced here, which is in front of the mirror, which is inside, which is on the left-hand side region, then your image is virtual and your Q is negative. Because the image lies within the forbidden region. This is the forbidden region for your outgoing light rays. It is not possible for the outgoing light rays to lie within this region because the light rays will go through the glass. Okay. Do you have any questions so far? Maybe I need to, I need to ask you whether you understand this or not. Hopefully everything is clear, yeah? Now, let's talk about the focal point or the focal length. In order to know whether the focal point is, the focal length is a positive value or a negative value, again, you draw your convex lens. This is for the convex lens, yeah? And then the light rays are coming from the left-hand side. And then, of course, it will converge on the right-hand side. Am I right? This is very intuitive. Okay. So your focal point here lies inside the outbound region. So the value of F should be positive. Okay. And then I have another one, which is for the concave lens. I draw this like this here. Okay. And then I have my light rays coming from the left-hand side. And then for some reasons, these rays are getting diverged. And then if I extend my, I'm sorry for my bad drawing. Yeah? Maybe I should use the figure here. So I have, again, I repeat, yeah, I apologize for this, yeah. I apologize for my bad drawing because I'm drawing using my mouse. Yeah, for this particular case, which is we are dealing with the concave mirror, the rays will be diverged. Okay, the rays will be diverging. Okay, should be like this, here to here, here, and then you need to extend the outgoing rays, and then you will be able to see that the focal point is on the left hand side. So the thing is, we divide this into two regions, two sub-regions. So of course, we are focusing on the light rays coming from the left hand side. Then this is our inbound region. And then, of course, our light rays will go through the mirror, and then the right hand side is our outbound region. The light rays seems to be diverging. So if you extend the outgoing rays, actually the extended rays are focusing at a point here. So this is the focal point. Unfortunately, the focal point lies inside the inbound region, which is the forbidden region. It is not possible for the light rays to be located on the left hand side. Am I right? So this is the forbidden region. But the thing is, the focal point for the concave lens lies inside the forbidden region. Then the F here should be always negative. Okay. So I think that's all for today. And then for our next coming lecture, I'll be focusing on the lens makers equations because once you know on how to decide whether it's the value of P and Q, I mean, once you know how to decide whether they are positive or negative, so and then after that you are ready to use the lens makers equation. And then you also have the thin lens equation. I'll introduce you to those equations later. Yeah. So this is based on the textbook, yeah. Then normally when I was at your age, when I did my degree, I've also used to this particular slide. I tend to remember things. Okay, it is quite confusing. But the thing is, you need to know on how to divide your your region into sub-regions, and then you need to know whether it is inbound or outbound, and then you need to identify which region is the forbidden region, and then from there you are able to deduce whether your P is positive or negative, or your Q is positive or negative. And of course, when you follow my rules for the mirrors as well as the lens, yeah, you don't really need to memorize this here. So of course, for the image height, so if your image is being formed above the principal axis, then your image height is positive. If it is forming downwards here, then it is negative. Okay, your image height is negative. So it is something intuitive. So I'll introduce you to these equations, this guy as well as this guy, next during the next coming lecture. And then, yeah, now I'll end recording my lecture, okay?